I am the only thing separating you from lunch, so I guess I have to be extra engaging, which is a challenge. So my talk is very different from what we've had so far. So everything so far has been kind of big thinking, and I'm going to present some results from an empirical study that I did, and it's one of these studies that I think shed some interesting light on the variation in the quality of state tests. It's not an ideal study, but I think there are some interesting results here. So, I don't have to spend a lot of time on the motivation for this work. I mean, state tests are being used for an increasingly bewildering array of decisions about teachers and schools. And of course, it's imperative to verify that improvements in test scores are actually within the power of teachers. And in this case, in this context, because I was affiliated with the Gates Foundation's Measures of Effective Teaching study, they were also making advice about how to construct weights for multiple measure teacher evaluation systems and set aside the question of whether or not that's a good idea. I was wondering the extent to which instructional sensitivity is relevant to those decisions about how to set weights. And so this study is among the first to compare sensitivity across subjects in math and English language arts, to include multiple widely used measures of pedagogical quality in sensitivity analysis, and to use such a large sample of teachers from the full MET database, about 2,000 teachers, and data of the type to be used in new teacher evaluation systems. So again, I was sort of an ancillary part of the MET team, and so I had access to these data somewhat early, and it was so interesting to me. Every time I'm in the room with economists and they're talking about value added, they're stunned by the idea that different tests might give you different value-added measures. And so that was kind of what I wanted to illustrate to the team. So the two questions that I asked were, to what extent are state assessments of student achievement sensitive to differences in observational and student survey measures of instructional quality? And then how do optimal weights for multiple measure composites differ across state tests with different levels of sensitivity? So again, I use data from the MET study. For those who aren't familiar with the MET study, the purpose of the broader study was to help districts make decisions to design effective evaluation systems for teacher improvement. And what we've seen is that many states and districts have basically adopted the MET's recommendations, which were more or less roughly equal weighting on value-added observational measures and maybe student survey measures. And so the MET study used about 3,000 teachers from 6 districts in 6 different states. And 2 of those states I exclude from my analysis because of smaller sample sizes. And I only use grades 4 to 8 math and English language arts because those are the grades for which I have VAM data. So our outcome measure is value-added measure on the state assessment. And they use a random effects model. It might not be the perfect value-added measure, but it's the measure that they used, and so that's the one that I used. So the measures of instruction that I have access to are based on observations of classroom instruction that were rated on a number of different rubrics. The tripod and the class rubric are, the class and the framework for teaching rubric are 2 of the more well-known rubrics. Obviously, the Danielson rubric is, I think, by far the most widely used rubric that's been adopted in districts and states. Those are subject area agnostic rubrics. And then we also have a math-specific rubric, the MQI, and an ELA-specific rubric, the Plato. And then there was also a student survey measure that was administered to all the students in the teacher's class, and this was the Tripod Student Survey developed by Ron Ferguson. And so I should say at the outset, right, tests, assessment should not be designed with the idea of being sensitive to every variety of instructional difference, right? Rather, assessment should be designed to be sensitive to instruction on the content in the intended domain of inference from the assessment results. Also, assessment should be designed to be sensitive to the form of instruction seen as good or high quality by the agency creating or administering the test. And so I think part of the discussion that we need to have and the field needs to have is what is good instruction? And so for this study, I just make the assumption that the folks who developed these tests many years ago think that class and framework for teaching represent good instruction. And maybe they don't, and maybe their tests are sensitive to some other measure of good instruction. Of course, we don't know that. These are the data that we have. But in any case, for the state test results to be validly used to make inferences about teachers' instructional quality, it's essential that the tests be demonstrated to be instructionally sensitive in these ways. Again, to the content in the domain and to the type of instruction that's high quality as judged by whoever's making that determination. So the methods are really extremely basic because I wanted to do the kinds of analyses that would be feasible in districts that are going to have these kinds of data. So I start out by just looking at correlations of VAM scores with the instructional quality measures, and I do these separately by state. I also did them separately by grade and state, right, because, of course, we're talking actually about different tests within states across grades. Turns out that there's much more similarity within states across grades than there is across states. Then I take away some outlier teachers. There are some teachers with really huge value-added estimates, so I take those out and see if anything changes. I look for evidence of nonlinear relationships. I do subscale level analyses and grade level analyses. And basically, I define sensitivity as any positive and significant relationship in any of these analyses. So it's an extremely liberal standard. And I wanted to sort of give states the benefit of the doubt in terms of the sensitivity of their tests. And then for the second part, I derive optimal composites using simple multiple regression approaches, standardized regression coefficients. And here I'm predicting the optimal composite for predicting next year's value added and the optimal composite for predicting an equally weighted average of value-added observations in student surveys. And again, I'm just replicating what they did in the Met reports. So I'll jump into results. So the first table here shows correlations of state test VAM scores with pedagogical quality measures by district and subject. I blanked out the districts. If you really want to know which state is which, I'll tell you offline, but that's not available in the paper. And so what do you see? Well, there are a few patterns that you see. First of all, none of the correlations are big. The biggest correlation is 0.28. We do see, although it's not shown in this table, that there are some significant differences between districts. So some tests seem to be more sensitive to these quality measures than others. For instance, in English Language Arts, District 2's test is much more sensitive than District 4's test to the tripod. In fact, District 4's test has actually a negative correlation, a small negative correlation with the tripod. We see some districts where the tests don't correlate with any of the quality measures. None of the correlations are significantly different from zero. So actually, District 4 in both ELA and math has no significant correlations in this table. So if you take out outliers, I'm not showing you that table, but that doesn't really change anything. All right, so the first set of results suggests there is some sensitivity if we use this very liberal definition of sensitivity, but there's also a lot of insensitivity. So now I'm trying, okay, well, these results are sort of a little bit disappointing, so let's try and find more ways to give more state tests credit. So I do some nonlinear analyses that don't show anything. I did quadratic and logarithmic transformations. I find no significant relationships of any kind of transformation that I can come up with. I do know that some other folks on the Met team have looked for evidence of threshold effects and seem to have found some for certain subscales. Like, for instance, on the class, I've heard anecdotally that a certain level, there's a sharp increase, or there's a sharp correlation at low levels on sort of classroom behavior management, and then at a certain point that levels off, right? So it's just about your classroom has to be reasonably functional, and then after that it doesn't really matter. I didn't find any of that in my analyses, but I know other people have found that. Then I also looked at subscales. So each of these instruments contains a number of subscales that were rated, and so I break it out by, I do the same correlational analyses just looking at subscales. I also look at grade levels. And so here you just have a proportion. So out of the subscales, out of the 12 subs, so for instance in the top left corner there, that says for District 2, out of the 12 class subscales, 0 of them had correlations that were statistically significant. So there's 117 in this table, and 4 of them show significant correlation. So that's actually less than chance. So, so there's no evidence of subscale sensitivity that taking the average composite score is masking anything at the subscale. And at the grade level, again, there's really only no evidence of grade level correlations in these states where we have little evidence of sensitivity. And then the last, to answer the second question, again, I was interested in understanding how do the differences in sensitivity relate to the optimal weights in these composite evaluation systems. And again, why am I interested in this? Well, because this is how states and districts are using these data right now, is to create composite ratings of teachers. And this was a fundamental goal of the MET study. And so if the goal is predicting next year's VAM, then more sensitive assessments are given lower weight in the optimal composite. And this makes sense, right? Because if you're trying to predict next year's VAM and VAM doesn't correlate with anything, then you're going to put all the weight on VAM, right? But if other things are correlated with VAM, then you'll give a little more equally weighted. If the goal is predicting an equally weighted composite of VAM, tripod, and the observational quality measure, then I don't find the same kind of pattern in terms of the relationship of sensitivity to the weights given. And VAM is almost always given the smallest weight in these optimal composites because VAM is the least reliable of the 3 components. I also find that the weights on VAM are generally higher in mathematics than in English language arts, and again, that's because of reliability. All right, so how do we understand these results? Well, one interpretation of the results is that most of the state assessments show modest sensitivity to one or more pedagogical quality measures, with just one exception. And a second interpretation of the exact same results is that each of the assessments is insensitive to at least one and often multiple measures of pedagogical quality. And so the difference between, I think, these two interpretations, which are both reasonable interpretations based on my results, lies in our expectations regarding the appropriate correlations to indicate sensitivity. So if the goal is to have correlations of 0.2, which is not a particularly ambitious goal, but if that's our goal, then most tests will fail on most of the quality measures. If instead the goal is to have correlations of 0.1, then we say, okay, then our results are more positive. So another decision that we have to make, in addition to saying what is quality instruction, is to say how strongly correlated should these things be? And I haven't seen anyone who's put forth a claim about that. And of course, states and districts need to begin studying the sensitivity of their assessments rather than simply assuming them to be sensitive. So when they find that most of their tests are insensitive, as appears to be largely true in some of the districts in this study, then they have to decide what to do with these results. At a minimum, the response should include detailed study of the tests and the observational measures to ensure that they're aligned and that the quality of the data are good. So where do we go from here? Well, again, in this case, these tests were not constructed to be sensitive to these particular quality measures, right? So I think the first step is we need to decide what good instruction looks like. And then we need to foreground sensitivity, and I want to echo the earlier point about also foregrounding alignment in the assessment and accountability argument. So if tests are constructed to be sensitive to good instruction, but they're not, then that is a serious problem. And I think that, of course, there's also instructional content, which is totally ignored in this presentation, right? Because Jim's definition talks about quality instruction on the content being tested. That's ignored here, although I have a separate paper where I do have some measures of content and find even more disappointing results. Right. And then the final point is that I think we need to start to work to, and Jim's already done some of this work and other people have as well, but to determine what makes some tests more sensitive to instructional content and or quality than others so that we can help put it, again, up front in the test construction process. Thanks. Questions? Yeah, you can study grade level differences. So the problem is that at specific grade levels, you've only got maybe 60 to 80 teachers, so you just don't have power to detect any difference, any statistically significant differences between grade levels. But you can do the exact same analysis at the grade level, and I have done that. Right. So I did a sort of a supplementary study where I surveyed teachers and asked them what topics they taught, and so that paper is actually under review right now. But again, I find even worse results for that paper than for this one. Yeah.
Given that the tests that you were using and indeed the measures of quality you're using were kind of designed to do this, if the corrections you want, that is, tests designed to be more instructionally sensitive, accurate reflections of what you would say instruction and stuff, what would you think would happen, Morgan?
Well, I think that's a very challenging question. I mean, I think that we really need to have this conversation about what good instruction looks like. And right now, what we've defaulted to is good instruction is Charlotte Danielson. And I think that maybe that is good instruction. I don't know. But if we can't have some kind of agreement about what the test should be correlating with, then how can we make a judgment as to whether the test is doing a good job of that or not?
I think we can. I mean, I'm a little bothered by the requirement that we conceptualize instruction in one particular way. The real focus is on whether kids learn, and we've been reminded that several times. The reason you do instructionally sensitive tests is to increase the likelihood you'll be teaching in a way that kids learn. But why do we have to identify what Charlotte or anyone else thought was good instruction? Why not simply identify a half dozen key variables of classroom practice and go with it? Forget about what's good.
Well, because I think, again, and this gets to Neil's point that I think he was trying to make earlier, so I found basically close to zero correlations or very low correlations. So is that because I measured the wrong, I didn't measure, but is that because we measured the wrong instructional variables? I don't know. Or is it because the test is bad? So maybe if we had measured different instructional variables, then I would have found correlations of 0.4. And there's no way to know. I think that's why we need to come to agreement on what we want these tests to correlate with. And once we can do that, then we can do the correlation, and if we still get 0.2, then that's a problem.
Can you make a career out of this size correlation? I mean, I just wondered.
I think that there's a reasonable. I think a lot of people are making careers out of this size correlation. So I don't know about good researchers, but certainly folks in states and districts.